Now let's begin our last section of this course. This section is about data visualization, and the library we're going to use is Matplotlib. Matplotlib is useful for showing trends, comparisons, and patterns in the data, and these are the most commonly used function that we have in Matplotlib. So we have line plot, that is PLT plot. PLT is again a short name that is similar like pandas as PD, numpy as NP, and then we have bar chart, that is PLT bar, that's a function we have, and we also have pie chart, histogram, scatter plot, and these additional functions also we use during plotting. Okay, and now let me import the library. Library name is matplotlib. That's the keyword we use to import libraries in Python, and the library name is matplot. And we're going to import the sub module, that is pyplot. Mostly we use pyplot for plotting. Okay, and that's the short name, that is PLT, as an alias PLT, and that's the library name. And now let me plot a very first basic example, and then I will explain these functions that are here. Okay, these functions I will explain, and after that I will import an external file, that will be a CSV file, and then I will use pandas PD series to plot those these plots. Okay, now let's assume that we have sales data for an year, and we have months that would be a list. Okay, that would be a list, and we have January sales, then we have February sales, and now let's have a sales for 6 months: March and April, May, and June. Okay, these 6 months we have, and now let's have a sales data, and then sales is equal to, that would also be a list. You see, if you use square bracket, that would be a list. If you use curly bracket, that would be a dictionary, and if you use parentheses, that will be a tuple. So we are using list, and also it's also not a numpy array because we have a different data types there, so it's in a list. And let's assume for January we have sales, let's say $69, and then 89 for February, then 90, and for April let's assume 188, and May let's say 199, and for June let's assume just few numbers, because I will just explain these functions to you. Okay, and this is a sales data. Okay, so we have 6 months, and we have sales for 6 months, and the PLT, I'm going to plot the PLT first method. Okay, that's a line plot, and PLT dot plot. Okay, and we need to provide two values. One is an x-axis and then the y-axis. And for x-axis, I'm saying you need to plot months on an x-axis, and for y-axis you need to plot sales data. Okay, that's the very first function, and that's the very first chart we're going to plot. Okay, and then I will use those functions that are above to explain what is an x-axis, what is y-axis, what is legend, what is grid, and why we use PLT show. Okay, all right, so you see that we have these months values are on an x-axis, and the sales values are on the y-axis. And now let's use these functions, because at this point you see that we do not have any label for x-axis, and we do not have any label for y-axis, right? And for x-axis, that's the function name is x label. Okay, you see that's the function we have, x label, and I'm saying that these are months. Okay, that would be a string value. Then you also have other options to change the font size, change the color, and also at some point to change the opacity, right? And now you see, now we have x-axis, you see months appear there, and for y-axis that would be PLT y label. You see that's a function, we have, and those values for y-axis we have sales, right? And you see now we have also labels. This is an x-axis, this is a y-axis, and another function sometimes we use it based on scenario. So everything is based on scenario. Okay, based on scenario. So now let's say I need a title, that would be a month versus sales. Okay, months versus sales. So all right, so it's not a while label, it's title. Okay, so we have months versus, so that's a title, that's an x-axis, that's an y-axis, and that's the line plot. Line plot we use to see trends over time. That's the idea. Whenever you have to use a line plot, you're going to see a trends in the data. Okay, so these are the basic function, and we can also sometimes use PLT grid. Okay, you must be familiar with the PLT grid, maybe in Bootstrap, that if you use this one PLT grid, you will see these vertical and these the boxes will appear inside your plot. Okay, and by default the size is 6.8 inches by width, and 4.8 is the height. Okay, that's the by default size. All right, and the last function we have here is PLT show. PLT show you need when you're using Spider, because that's the Python code and you want to display your plot. But for Jupyter Notebook, PLT show is the default function that is already executed when you run this cell. So even if you have this PLT show, it will not cause any issue, or if you do not, if you have or if you do not have, it will not cause any issue in Jupyter Notebook. Okay, that's function mostly used when you're using a p.py extension and you need to display these plots. Then you use PLT show method that I want to see that plot. All right. Okay, so that's the basic idea for Matplotlib, and these data is I manually created, and that's x-axis values and that's a y-axis values. But most of the time we have to read an external file, right? That's an external file. That could be a CSV file, or maybe an HTML file, or maybe a JSON file. Okay, so now let's import an external file and start plotting different kinds of plots we use in Matplotlib. So we have different kinds of plots. You see PLT plot, that's a line plot, then we have bar, pie, histogram, scatter plot, and then we also have box plot. Okay, now I need to read CSV files. That means I need to import another library that will be a import pandas as PD, because I need to read CSV file, and that will be df and df PD. That's a short name, PD read CSV. All right, that's a CSV file, and where this CSV file is in data, and the name of the file is sales. That will also upload on the canvas. Okay, that's the file we have. And now let's look at the data frame we have. Okay, that's the data we have. So now these columns are series. Just remember, these columns are series, pandas series. This is the first column, that's a week, and that's also a sales data. We have week 1 to week 20, and then we have company A sales, company B sales, company A complaints, and then company B complaints. So here we will do a lot of comparisons. Okay, that most of the time you have the data, you need to find the patterns in the data and see any interesting thing you can find using visualization. Sometimes stats are important, but visualization is also important to show to bigger audience. So we have company A, B complaints, company A rating, and company B ratings. Okay, these are the columns we have. Now let's do a quick analysis. That what columns right now you can see these columns are, you can clearly see that these all are the columns that we have. But sometimes we have, if your CSV file have 100 of columns, then you will see that dot will appear, then you cannot see those column names. Okay, and for that one, there's, you familiar that df dot columns, that's a function we have, and it will give you a list of columns that we have in this data frame. And another function important is that you can look at the d types, what different data types you have, because if you trying to plot, few plots require data type, because if you're looking at the distribution, and that distribution requires numeric values, right? So for week we have integer values, and company A is integer, and company A rating is float. You see these are decimal values we have here. All right. And another function important is that you can also quickly look at the description. Okay, that will describe, that's a function that will give you 25 percentile, 50 percentile, 70 percentile, maximum value, minimum value, standard deviation. So that's a quick analysis. If your columns are numeric, you can easily look at these values. That will give you an idea what kind of data you have. All right, now I will start first with the line plot. Okay, the line plot is used to show change over time. That's the thing. And here I'm going to plot week on x-axis and sales will be on the y-axis. You see that week, these week we will be on x-axis, and company A sales, that's a company A sales, that will be on y-axis. All right, now let's begin. The function name is PLD, and the function name is PLD is the short name, function name is plot, and I need two values. I need x-axis, I need x-axis, and also a y-axis. But there are different parameters you can also pass to this function to change the styling. Okay, and the first thing is to x-axis, that will be a df. Okay, we have a data frame df, and I want to plot week on x-axis, and I want to plot df sales data on y-axis for company A. So that's a company A. Okay, that's the plot we have. And now let's try to understand. You see, line plot is used to show change over time, and we can see that something is wrong for week 5 to 7 because we have low sales here, and then we also have low sales. So that's give you a quick analysis that how company A is doing. All right, and now let's use those additional functions that we have, that we already discussed. These are the additional functions, and I'm going to give x-axis, y-axis, and then I also change the styling. Okay, so the x-axis is, we know at this point we have weeks, and y label is that we have sales, and that will be a weeks versus sales, and that's it. Okay, now another thing important is that you see that x-axis, you see it automatically converts into a float value, but I like to plot these weeks as 1 2 3 and 4 5. There's another function that is useful, that is xticks. Xticks mean that you can also change these values. Okay, and that would be a plt xticks, using xticks, and it takes two parameters. The first one is that I need to provide the tick location. That's the tick location, means the first location for week 1 is 500. Okay, that's the location, and I need to provide those values. That would be a df week. Okay, it's with capital W. And the second value I need to provide is that what would you like on x-axis. I like to print out 1 2 3 4 these weeks values. Okay, and I'm going to plot as week, the same thing, and dot as type, because those values are integer. I need to convert into a string, and that will be an str. Now you see, now we have weeks 1 2 3 4 5 6 7 8 15. Now it makes more sense, because week 5 and 7 we have low sales, and we also see that there is something wrong in week 15 to 17, and then we have the maximum value here for week 18 and 19 and 20. These weeks are big nice. All right, now let's look at few more parameters that we can pass to this function, and that would be a color. Okay, you can also change the color. Let's say I need color red, so that's an RGB color. You can also use color picker online to give that hex code, I guess. Let me show you. You can use color picker online, and yes, that's the hex code. Let's assume I need color. That's the color. Let's assume this one. Okay, that's one. I just need that code, and just come back here and give that code here. Okay, so that's the color. And the color you can change, and you can also change the marker. Marker is that I'm going to put scare. Okay, that's scare on these data points. So first value is 500. You see, that's the data point, that's the data point, that's the data point. And there are different kind of markers you can use in Matplotlib. Just search marker. Okay, not marker, that's a Matplotlib. Okay, these are the markers. These all different styles you can use as a marker. Okay, let's assume I need this star. That's that star here. I just need that sign, that symbol. That will be a star. Now you see that star appears there, but the color is not very nice. Now let's move back to red, and you see that star is there. Okay, and that's the one I already used, square. And pentagon you need P, and hexagon you need H, the capital H. Okay, now let's put H here, capital H. Now you see that's a pentagon here. All right, what else you can use in this function? Okay, so you can also change the styling. Okay, styling means these line style. You see these line, the current default line style is solid line, and there are different line style. That is lines style. Okay, line style, and that will be equal to dash dash dotted. And that's, you see now that's the line style. And I think more than 4 and 5 different line styles available in Matplotlib. Line styles in Matplotlib. Okay, these where, yeah, these are the different line styles you have. Okay, you just need to look at what value you have to pass here. And let's dash dot, it will be a 1 dash, and after that will be a 1 dot. You see, 1 dash then dot. Okay, and if it's a solid line, that will be 1 dash. Okay, so you can see these different line styles. All right, and now that's the company A sales data. Now let's have company B sales data and try to understand that why we need line plot. And let's try to understand. And that's the company B, and we need to change. That's a company B, yes, you just need to change company B, and that's a company B data. Okay, and let's change this one to green. You see that's a green. And what else? Okay, so what now we can clearly say that company is more stable compared to company A because we do not have any drop in values. And most of time, another important function is a legend that will explain in a few minutes. That most of time we have to do a comparison what our company is doing compared to another company. Okay, and in that case you can use the same function. That's a company A plot. That's a sales for company A, and I'm just going to copy the same line and use the, after that I will plot company B, and that's a company B. Okay, and you'll see both lines appear in a single plot. And you see that's both line. Now problem is it's difficult to understand that one. And now let's change the company B into green. Okay, now we can see the comparison that companies have some issues for week 5 and 7, but that company is very stable. And also we can differentiate with legend. That's the important function that is important to differentiate these lines, because I don't know what green line is saying, and I don't know what red line is saying. So the another parameter important is label. Okay, that's LABL, and that would be company A. Yes, that's a company A. And the second one is label, that is company B. Okay, that's a company B. At this point, A is not there, and the function we need is PLT legend. Okay, that's a PLT legend. That's the one. Okay, now you can see that company A is a red line and company B is a red line. All right, then we in Matplotlib we also have a bar chart. If for this data is a very small data, that's we have data for 20 weeks, but you have a lot of data that would be line plot to see. Line plot is used to see the trends. But another important plot is bar plot. If you have a limited data, then you can go with bar plot. Okay, bar plot is useful again to compare values clearly. Okay, if you have limited data, and that would be a PLT bar. Okay, the same thing. And I'm going to I'm going to copy this stuff from here. So every function takes different parameters, so I just copy the first x-axis and y-axis. Okay, just x-axis and y-axis, because I don't know what's the other function this parameter this function takes. You see, again, everything same, but the data is limited, and I can see uh, uh, clearly the sales value here, because here you need to compare with the y-axis. Okay, so y is the first value for company B is maybe around 200 and maybe 300, right? But here I can clearly see. But again, that's for limited data. And what else we can use the same, all other functions also applies easily here. These all function, because these are the PLT methods, sorry, PLT functions, and you can just copy paste for x label, y label. But these are supported even in another visualization libraries. Maybe if you are using Seaborn, that will be the same PLT x label, PLT y label. You don't need an x and another function for Seaborn. Okay, so the same thing that is for, now you see that we have 20 months of 20 weeks of data, and we use a bar plot. We have x-axis, y-axis. Okay, now another function important is histogram. Histogram, why we use histogram? It sometime we need to see the distribution of the data. Okay, distribution of the data. That's clearly, that takes a one, and takes only a one numeric column, and you can look at the distribution. For instance, I like to see the distribution of let's assume company A. I like to see the distribution of company A ratings. Okay, that will give you an idea. That's the histogram. And for that one, it takes only one column, and the function name is plt hist. Okay, that is a plt histogram. And I'm going to look at the distribution of company A. Let's say company A. Okay, that's the distribution we have. Okay, and I didn't provide any parameter at this point, because there are other parameters we can forward. For instance, the bins is used to control the width of these bars. That will be bins, let's say 9. Okay, you see, now it will be a less, and these are together without any spaces. But if you have more bins, then they will be separated. Let's assume 90 bins, and you will see these kind of lines. All right, and let's go back to bins 8. And another important function, another important parameter here is that you can also forward the edge color. Okay, it's ADGE, and that is color, and that will be, let's assume that will be a black. Okay, now that's the edge color. All right, and you see, I said to you that the default size is 6.8 by 4.8, but there is another function that you can use, that is you can use to control the width and height. And that would be a PLT fig size. No, that's a PLT figure, and then we need to provide fig size, and that's, you need width by height. Width will be, let's say 9, and the height is, let's say 5. Okay, now look at this plot. That's different with different size. All right, and if now let's again try to understand this company A data, the sales data, that we can see that company has several low sales values, and some sales values are very high. Okay, that's I can see that, you see these are low sales value, these are also low sales value. And if we plot company B, let's have company B here. Okay, and that is more stable, and we do not have a lot of low sales value. Okay, and another thing you can do is to plot on top of each other, and that gives you an idea of company A, company B comparison. That is, again, you have to just Okay, so if you see these kind of numbers, you see that number is no need to confuse that you just need to use a PLT show method and you will not see those numbers, because that's all executed and it show these values. But PLT show method, that we don't want to see the internal processing what happened. Okay, and now let's compare company A and company B. That would be again PLT show that's a company A, and that's no, sorry, that was company B and that's a company A, and I'm going to label this again. You see that's a function, that's a parameter we have, that's a company A, and the second one is company B, that's B, that we can now compare. And we do not have an x-axis, you can now use x label, y label, and what else. Okay, so you can also use PLT legend, and you see there's a company A, company B. Another important function is, because these I cannot see what is behind from behind these bars for 750 and 1000, because I cannot see company A's data there. Another important function is parameter is that you can use alpha, yes, that will give you an opacity, and opacity, let's, for company 0.6, it's on scale 0 to 1, right? And less the opacity, it's just giving, I'm just giving transparency. Let's remove this one. You see, now I can see what is behind company B data, that I can see that there is a bar for company that's nearly around here, near 2 sales there. All right, now another important function is the box plot. I use a lot box plot, because that's give you a quick observation and analysis of how sales data is working, or what's different kind of stats we have in the data. And that would be, let me plot, and then I explain how to read the box plot. That's again very important. That will be a PLT box. You see, that's a function we have, box plot, and I'm going to use company A data again from here, and after that again I will compare. Okay, that's the company A data, and let's just plot that one. Okay, that's the plot. Again, you see, if that kind of messy stuff, if then simply PLT show, you will not see that one. And another function important is that you can use no, it's tick. Yes, that's because the old version was, that function was not depreciated, so it's a new version. That's a tick label. Okay, tick label will take list, and because you see that's the one here, I don't want one here, that's the company A data, but that's the company A, or whatever you like, you can just put that string here. Let's say company A. All right, now let's try to understand this one. So box plot, it's a distribution of data that gives you 25 percentile. That's the 25 percentile. That's the 25 percentile, and that's again 25%, 50 percentile, and then that's the 25 percentile again. Okay, and that's the minimum value here for company A. That's the minimum value. It's also called box and whisker plot. Okay, and that's the minimum value we have for company A, and that's the maximum value we have for company A. Okay, maximum value is 2000, and the minimum value is somewhere near maybe 100. We can see it's nearly, you see, 150. No, the minimum value is 80, so that's the minimum value. Okay, that's the minimum value, it's an 80. Okay, so that's 25 percentile, 25 percentile, 25 percentile, 25 percentile, and that's the median value. And the median value is, let's say if you have 10 numbers, let me explain. That's a list. Okay, that's a function, list a, just that's just a random variable, and that's an 8, 9, These are just again some random values, and let's say 9 again, and that's a 10. So median will be, that will be sum of these two numbers then divided by 2. That's the median. For company sales A, then you have to find these two middle values and divided by 2 if they are even. 1 2 3 4, yes, if they are even. If they are odd, then you already have the median value there. So that's the list I have. Now let me plot this one using this list. So explain you the 25 percentile, the minimum, maximum, and the median. Okay, and you can see, okay, so that's 8 is minimum here, right? That's a minimum, and that's 25 percentile, and the median is saying it's 9. 9 mean the sum of these two numbers divided by 2, because we have even values. Even values mean that you have to divide by 2 by taking the middle two values, and if values are odd, then you already find the median there easily. Again, these few stuff I can see PLT show, you don't see that. Okay, that's you don't need that. I'm just trying to explain that's how to read this box plot. So we have minimum value, then we have 25 percentile, 50 percentile, 25 percentile. That's the maximum value we have. That's the company A. And if I use company B, again that's again of a comparison, and that's a company B, that's a company B, okay, that's a company B. So we have minimum value near something around 100, and the maximum value is again 2000, nearly $2000, and that's the median we have. Now for comparison, we can plot, we can use multiple box plot in a single chart, and that would be, you have to use PLT box plot again, and here you need to provide a list of values, list of columns. Okay, that's the list of columns. And now I need df, that is company A, and okay, that's a list. Here separation, and df, that's company B. Okay, that's company A, company B, and let's use plt.show. That's a plt show, and I also need x, what's the fun, text label, text label, and that would be again a list A, and the second will be B. Okay, that's the company A, that's the company B, and we can clearly see that the median value of company B is greater than the median value of company A, and the company B is performing better compared to company A, because if you see that 50 percentile is greater than the 50 percentile of company A. Okay, now we, another plot important is the scatter plot. Scatter plot shows the relationship between two numerical variables. Okay, and now let's look at two numerical. We have company A. Okay, that's the company A sales. Let's have company A's sales comparison with the complaints. We again trying to find any patterns that we can see inside the data. Okay, and the scatter plot, that is PLT scatter, you see that's the function we have, and that's the comparison between two numerical variables, and we're going to put company A sales data here, and we're going to plot df uh, company A complaints. Okay, all right, now again try to understand this plot, that if we have less sales, you see that's, okay, now let me put x label and y label to understand this one. That will be the x label, and for x label we have, okay, so the first one is x-axis and that's the y-axis. So y-axis is complaints and x-axis is sales. Okay, that will be a sales, and PLT y label that is complaints. Now I can do a comparison. So if we have less sales, we have a lot of complaints here. Okay, that's the pattern I found for company A. And for company B, so you can also change now colors. If you like any other colors, you can change. There will be another parameter that will be a color. And labels, you can also change labels. Okay, and for that's company B. Okay, oh, for company B's there is slightly a different patterns. Okay, that's company B sales. Oh, that's the problem, because you also need company B complaints here. And for company B, similar trend, we can find that if we have more complaints, then there are less sales. Okay, and in case if you need to do a comparison, you just need one plot. That will be one plot here. Let me move, because that will be one plot here, and this will be company A, that will be company A. You see, and again you need labels and legends to differentiate. That is label. That's a label. That's A, and the second one is B. Okay, and that's a B here. And if you use labels, then you need a function that will be plt legend. That will be by default true. That's a company A, that's company B. To do comparison with using line plot for their ratings. Okay, now instead of manually again plotting one by one, let me copy this one here, and that's a company A sales, company B sales. And now let's move to another column that we have is company A rating. Okay, let's look at the rating, and do we find any patterns there. That's a company A rating, and that's a company B rating. All right, you see that for sales, if they also have less, when they have less sales, then their rating is also not very nice. You see, that's a complaint. That's not a complaint, that's a rating. Okay, the rating is here, it's low for company A. See, for company B it's nearly around 2.8. This is how we read. So we have to read x-axis and y-axis. On x-axis the sales $250, and the rating is nearly 2.8. That's also not nice. Now let's look at the pie chart for sales for company A and sales for company B, and let's look at the first half and then also look at the second half for let's look at the first half for the company A, and then the second half for the company B, and try to understand the patterns there. The uh, first half mean the first 10 weeks. First half, that will be the DF company. That's a company A, and I need I lock. Okay, because I just need the first 10 values, and the first 10 values means that I will be brought from 0 and up to 10, and I need a sum of these values because I need to show the percentage there. Okay, and let's look at what we have there. First half, and these are the values. So I got 5,905. That's the total values, total sales values for company A. All right, and for similarly, I can look at the second half. The second half, that will be a DF company A dot iLock. The first one, that's iLock, and so it's square bracket, and now I need to start from 10, and I will leave the ending blank because up to the last row. And again I need a sum. That's a function. Okay, that's a function here. Okay, I have first half value and the second half value. Now let me show you print. That's the first half sales and that's the second half sales for company A. First half is 5,905. Second half is 11,350. And I'm going to use now pie chart. That will be a PLT. That will pie, and it takes a list because I need to show the distribution in percentage, and that would be a first half. Okay, that's a first half, and separate because list is always separate with comma, and that's the second half. And any other parameters, we will see other parameters in a few. So that's the pie chart we have. And now let's make it readable. Oh, not the print, I need plt.show. Okay, that's a function we have. Now let's use different parameters. So you can also move this line. You can put these spaces to it to not cause any issue. And now I need labels because I do not understand what this percentage, what this blue percentage is showing, and what this orange one is showing. It's difficult to understand. And labels, that is the first 10 week. Okay, and the first 10 week, let's move it weeks 1 to 10, and the second, that's again a list, and that is weeks 11 to 20. Okay, now we have the labels. That's a label, that's a label. Another, I also like to show this percentage inside. That's another parameter. This pct auto pct, yes, that's the one. And it will be a string with percentage sign in it. Let me check. Okay, that will be string, and after that you need, that's a 1.1 f, but why it's not in red? Auto pct. I forget to close this one. Okay, that's it. Now it's saying there's a problem. What problem we have? Closing parentheses does not match opening parentheses. I think that's the one. That's, you don't need. Alright, now again there is a problem. Incomplete format. I think that F is for one and you need another one. Yes, that's it. Okay, so now 34.2% is sales is week 1 to 10, and then so how can you read this pie chart? That means for company A, they have more sales in the second half of 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 the weeks. Second half means week 10 to 20, right? And if I now let me just copy this one from here to here because everything is same. I just like to copy this one from here and to analyze company B. All right, and I will see is there any patterns that we have there. Okay, the same thing, something is very similar for, yes, more or less same sort of patterns we find for company B as well. They have more sales for second half. Okay, now let me explain subplots and why we need subplots. Subplot allow us to show multiple related charts in one figure. Okay, and for our data, I'm going to do a comparisons for company A sales versus complaints and then their ratings. That's the data we have here. Company A sales, complaints, and their rating. and I do similar for company B complaints and their rating, and after that I will do a comparison, because the problem, it's not a problem, it's another efficient way of visualization, that you see, that I have to create these different plots to explain, to find the relationship between different variables. And subplot provides you this functionality that you can plot multiple plots in a single row or in a multiple columns. And from subplot we have to deal with axis, and for I need fig size, fig and axis, and I'm going to use plt subplot, and I need one row and three columns. Okay, that's a fig axis, because I need to plot on axis 0, axis 1, and same similar like in an array. And I need one row, three columns. You can also have three rows, one column, based on scenario, whatever the um, based on scenarios, or whenever it depends on space. Because if you have a slide and you need to show plots uh, using one row and you have very limited space, you will go with one row and three columns. And if you have more space, then you will go with one column and three rows. Okay, based on scenarios we plot these one, but now for this figure we have one row and three columns. Okay, and I also need, that's a subplots. That's a subplots is a function, and that's it. You see, one row, three columns, and they have their own x-axis, y-axis, x-axis, y-axis, and that we will see. Okay, now they are overlap, and now let me change the fig size. That's a fig size. Okay, and that will be equal to, let's use 15 by 9. Okay, oh, that's too big. 10 by 6, and that's a subplot we have. Okay, now we just created a chart, but we do not have any data in it. And for, so now we have one row and three columns. That means x, now we have x is 0, and for x is 0 I'm going to plot company's sales data, and versus that will be an x-axis. We're going to plot x-axis week, and y-axis we're going to have, you can also share this week column for these multiple columns. That's another different functionality that you have in subplots, that you also enable it. It's shared x-axis, but we do not share x-axis. I will manually plot this one. That will be a df week on x-axis, and df sales company A. Okay, and that's the data we have. And you can also change, now you can change the color, styling, different stuffs, and that's on the x-axis. That means you can play around with the x-axis. Here you have uh, set x set I think set x label. Okay, and that will be a week. Just guess that's a week we have here. And then you have to set y label, and maybe you need grid, and that's, you can also enable there's an x label, and that's a y label here. Okay, that's a y label, and we have sales there. Yes, and I need x is 0 grid. Okay, this is how you can play around, because at this point I'm playing with x is 0. And now that's a quick way. You see, before that we have to plot three different plots and to see the trends. Now you can simply use one plot, and week and company A, let's say complaints, and here let me again df dot columns, because it's difficult. Here company A, and I will plot this one, company A complaints, uh, complaints, and you will see that y-axis also changes. This is a sales data, and that's a complaints. That will be, the y-axis value will be different. Now you see that also plots this, everything is in on axis, in inside axis 0, but we don't in axis, that's we have no axis 1, that's the second column. Okay, here now it moves to second column. You see these values are also different, and we have complaints there, and that's the sales here. And you can also change fig size because you see they overlap. There is another function I will that is a plt tight layout, because if you see that kind of issues, that function. But before, let me plot these one. Okay, so company A complaints, and now the last one is rating, and that will be here. And company, sorry, what's the column name? Company A, that's the one here. And rating. Oh, again axis 0, that will be last axis is 2, 2, and that will be 2 here, and that will be 2 here. You see, and you can also change these different colors, different marker styles, different line styles, and even you can, you see these all are plot. If you don't like plot, you can also use scatter here. You see that's a scatter, and you don't like plot here, let's say it's a hist. Oh, for histogram we only have one variable, that's a distribution. What others we can use? Bar, yes, you see that's a bar. We have an x-axis, y-axis, and we have uh, different kind of plots in subplot. And that's the function I was saying, that is a plt tight. That's the function, that's a part tight layer. You see now they automatically set, you see they, before they were overlapped to each other, now they look very nice. Now you can also change the figure size because that's too big. Let's set to 8 by 6. 6 is too much. Let's move to 4 here. You see now they look nice. All right, what else we have? Okay, that's a subplot, and you can also plot, do a comparison between two companies. How can we do comparison? That you just need to copy this one from here, and you need another one here. This time that will be company B on x0. You see now we have two lines, and for here you just need to copy that one, and they automatically set a new color for, because we are doing a comparison. And that's the last one here, and this will be here, bank. You see we can clearly see what company A is doing and what company B is doing. All right, so that's about Matplotlib. And for Seaborn, it's also very similar. You, for Seaborn, most of the time Seaborn is used for categorical comparison. Okay, that's uh that's another library, and that these same functions are also available there. You need to import the Matplotlib for x-axis, y-axis, and they have different kind of functions to plot, again different kinds of plots, but the idea is very similar. That if you have to create if you manually need to create data, you can go with lace. Okay, that's a lace, and you just need to forward those lace. Matplotlib, Seaborn automatically understand that that's the data we have, and that's the data point, and that's the Matplot needs to plot on in the chart. And Seaborn's also similar, but if you have an external file, you just need to read that CSV files, and you need to forward these data frame columns. Those are series. Okay, those are Panda series. Okay, let me show you one series. That will be here, df, that is company A, and we're going to look at the type. Okay, that will be a Panda series. All right, and that's it for visualization. and let me know if you have any question.